Let's solve problem 21, where a game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed at P. Step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So, to solve this problem, we have to keep in mind a couple of things. First is that the path, it should consist of 7 steps, and another thing is that all the paths, they should be taken on or the steps on the white adjoining squares or the adjacent squares. So if we make a couple of observations, the first is the maximum that we can go towards the left is this limit. So we can go up to this path, and then we can go directly from here to above. We cannot go beyond that. And on the right, we already have a limit due to the edge, so we can only go up to this, and then we can take the other path. So now we have to find the number of ways. So if we see, when we move from P to this box, we can have only one way of going, and similarly we have only one way of going from here to here. So similarly, if I move to the next square, I have only one way, and if I move to this square, I have one way. However, if I move to this middle square, I can have one way coming from here and the other way is from this side, so I can have two ways to go there. So similarly, if I move to this square, so I can then have one way, and plus 2 are coming here, so I have then 3 total ways. And similarly, like if I check for this square, I will also have then 2 and plus 1, 3 ways. So if we see, there is a pattern that is emerging, that is that the above row, it has the number of ways based on the number of ways which are on the bottom row. So for example, this 2, in other words, it's a sum of the number of ways that I have here. So similarly, like if I apply this pattern, so I will have 6 for this square, and for this one I have only 3, and for this square I will have 1 and then 3, so that will give, sorry, that would be 4 now. 3 plus 1, 4, and then I get 10 and I get 9, and this one will be 9 again, and this becomes 19, and this Q, then it has 28. So the answer is then A for this problem. So let's solve problem 22. When a positive n is fed into a machine, the output is a number calculated according to the rule shown below. If n is even, then the output is n over 2. If n is odd, the output is 3n plus 1. So for an example, if 7 is input, then the output is 22. Okay, that makes sense. And if 34 is the input, then the output is 17. So that is basically divided by 2. And we have to answer that when the 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers? So when the final output is 1, we have to find the sum of all integers for n. So to solve this problem, we can set this problem in the reverse order. So we have our function as output equal to input over 2. So we can set it up like input equal to 2 multiplied by output. So let's say that this is one option we have. The other option that we have, that is our output equal to 3 input plus 1, or we can write it in the reverse order as input equal to output minus 1 over 3. So now we apply these two functions in the reverse order to see what like options we get and which one are legitimate. So we start with 1. The 1 is the last value or the final answer. So if I apply both to 1, I will get 2 or I get 0. So now if I apply in the next step, again the both functions, I get 4, and I also get 1 over 3. And if I apply this 0, so I get 0 and I get negative 1 over 3. So from here, if I see this is not possible, this is also not possible, and also this is not possible, it will just keep repeating it. So now let's go move with 4. So if I apply in the next of 4, so I get 8, and the second that I get is 4 minus 1 over 3, and 3 over 3 I get 1. So in the next step, now if I apply again, I get 16, and then I get 7 over 3, and for 1 I have 2, and I have 0. So this is, yes, 0. So this is again not possible. So I will keep these two. And now if I apply again this 16, I get 32, and I get 5. For number 2, I get 4, and I get 1 over 3. So 1 over 3 is not the possibility. So now let's move to the 6th step. So I get 64, and the second possibility that I get is 32 minus, that is 31 over 3. From here I get 10, and also I get 4 over 3. From 4 I get 8, and also I get 3, 1. So now if I see this is not possible, this is not possible. The possible ends are then 64, 10, 8, and 1. So if I sum these up, 64 plus 10 plus 8 plus 1, the answer is then 83. So E is the answer for this question. Let's solve problem 23, where 5 different awards are to be given to 3 students. Each student will receive at least one award. In how many different ways can the awards be distributed? So we have 5 awards which are to be distributed to 3 students, and it says each student will receive at least 1 award. So based on this condition, we can define our 2 test cases. So one of the test cases, there are 3 awards which 1 student will receive, and then the remaining 2 students will get 1 award each. The other test case is there are 2 students who will receive 2 awards each, and 1 student will get 1 award. So now let's find the number of ways for each of this test case. So since at the beginning 3 awards are available to all 3 students, so that is 3 choose 1, and since there are total 5 awards and choosing 3, so now 2 awards are left and 2 students are left. So it means then now there are only 2 ways that the awards can be distributed to them. So then we add the next, or look at the next test case. So here we have now one of the student is getting 1 award. So basically then 3 choose 1, it can be any of these 3 students, and now has available 1 award from 5. So that is 5 choose 1. And next is you can have now the remaining 2 students, so they can have 2 awards each. So the remaining awards after choosing 1 are 4. So it is 4 choose 2, and then 2 choose 2. Let's solve for the total number of ways. So let's solve this first, and that is 3 multiplied by 5 factorial over 3 factorial into 2 factorial and multiply by 2. So if I simplify, I get 60 for this like half, and similarly if we solve this we will get 90. So the total answer or the is then, let's solve problem 24, where a large square region is paved with n square gray square tiles, each measuring s inches on a side. A border d inches wide surrounds each tile. The figure below shows the case for n equal to 3. When n is equal to 24, the 576 tiles cover 64% of the area of the larger square region. What is the ratio d by s for this larger value of n? So what we have to find out, as stated, we have to find out d over s. D is the distance between the tiles and the edge, and also between the tiles. So this is actually d we have, and also we have d we can see along the vertical sides as well. Okay, and s is the side length. So from here we can make one observation. If n is 3, then the distance along each side is 4. So the number of distances. And if I just write it here, n equal to 3, and then the number of distances is 4. So now if I express the side length for the square in terms of s, I can write it as 3s plus 4d. And similarly, I can also express the side length in this side as well, 3s plus 4d. Now I can extend the same idea when n is equal to 24. If I extend that to 24, then the side length for a larger square would become 24s plus 25d. So In order to find the ratio d over s, I can express everything in terms of the ratios of the areas, because I am given that 576 gray tiles cover 64% of the area. So since it is a square and side length is this, so I can then write um, area for the 576 tiles divided by the total area of the square, and that is equal to 64 over 100. And now if I take square root on both sides, I get 24s over 24s plus 25d, 8 over 10. And now if I do the cross multiplication, I get then 24s 200, sorry, 40s equal to 192s plus 200d. And now if I rearrange, I'll get then 48s equal to 200d, and then d over s is 48 over 200. And if I further simplify this ratio, then I get 6 over 25. So the answer is then A for this problem. Okay, so now let's look at the last problem, 25, where the rectangles R1 and R2 and squares S1, S2, and S3 are shown here, and they combine to form a rectangle that is 3322 units wide and 2020 units high. What is the side length of S2 in units? So we have been told the width is 22 wide and the height is 2020. So from here, if we make an observation that the sum of the sides like S1 plus S2 and plus S3 is equal to 3322. So S1 plus S2 plus S3 is equal to 3322. And similarly, I can also write S1 minus S2, that is this, and then plus S3, that is equal to 2020. So I can write S1 minus S2 plus S3, that is equal to 2020. And now I can solve these equations like the substitution method or the elimination. So I will just use the substitution method, and if I simply subtract these equations from each other, it cancels out, this cancels out, and I will be left here is 2, 0, 3, 1, and 2s2. And if I divide both sides by 2, I can get 651. So that is the answer.